current, rate of flow of charge. Once charge starts moving, okay, till the chapters what you have done right now, the charge will just sitting idle. They're not moving. Now suddenly they start moving. So the moment the charge start moving, okay, so the rate of flow of these charges is known as current. I is equal to Q by T. Very important formula, formula number 1, which you need to write it down. I is equal to current is equal to charge by time. Flow of charge, how much charge is flowing? Let's say, what do you say, 10 charge flew in 1 second. So we'll say that will be the current. Now, how to go more in deeper? What do you mean by the charge flow? Okay, what is instantaneous current? Dq by dt, very small amount of what? Charge flown in very small amount of time. Average is delta Q by delta T. We all know this much. Correct. Now, to understand the charge in depth, Q is equal to what? Basically Ne. Ne means how many number of electrons it went. Okay, so the number of electrons that goes from one place to another, or that flows. So we can, from that we can say, okay, let's say 100 electrons went. So we get it like 100 electrons, and we already know the charge on one electron, 1.6 into 10 to the power minus 19. So this much of charge is flowing in how much time? Then we'll ask, because rate we are talking about. Rate basically means what? About time. Rate means what? With respect to time, how much? Or per unit time. Rate you can understand it as per unit time. So amount of charge going per unit time. So current important formula is I is equal to Ne by T. We know I is equal to Q by T, charge by time, and Q is equal to what? Number of electrons that are flowing. So Ne by T, that's it. So this is important. Now then next, what is it? Direction. Direction of current is taken as, see, earlier days people were very what do you say, superstitious. So they wanted everything to be related with positive stuff only. So what they have done, they have taken the motion of positive charge as the direction of current. So the direction of flow of electron will be what? Negative to that of current. So if the electron is flowing like this, so current direction will be conventionally like this. Okay, clear? This will be current, opposite to that. Okay, clear? But actually it is the flow of the electron that is constituting current. But still people were very superstitious. They were like just superstitious. Okay, so they wanted, what do you say, anything which is associated with positive is good, anything which is associated with negative is bad. Next, can you say it is a vector quantity or scalar? Put it on the chat section. A lot of people will say, sir, direction is there, sir, so it will be a vector quantity. No, direction is there, but it does not follow vector addition, so it is not a vector. A lot of people, they'll say scalar also, but more accurate we can go to the tensor. Okay, it has few properties of vector, few properties of scalar. If the option is scalar, put up scalar. If it is more detailed, tensor, it will be there. If not, put up scalar. Okay, SI unit ampere. So 1 ampere is nothing but 1 charge, 1 coulomb per second. Flow of 1 coulomb charge in 1 second. What is 1 ampere? Flow of 1 coulomb charge 1 second. That's it. We have taken a question. Charge is given, that is equal to t square plus 2t plus 1. And time is given. You have to find current from 1 second to 2 seconds. How many charges flown? So what do you do? At 2 seconds find the charge. So that is equal to, put in t, in place of t put 2. So 2 square plus 2 into 2 plus 1. So 9 by Q initial is what? At 1. So 1 plus 2 plus 1. So that is equal to 4. So current is equal to what? dq by dt or delta q by delta t. Here we are talking about charge, change in charge. So final minus initial by time, 2 minus 1 is 1. So that is equal to 5 by 1. So that is equal to 5 ampere. That's it. So very simple, just for the sake of taking, I have taken it, not very much difficult. Next is current density. This you should know it. Current density is nothing but current by area. Anything if you divide by area, you get the density of that. How dense it is means per unit we are talking about. Per unit, per meter square, how much it is. Okay, clear? So SI unit is what? Ampere for the current per meter square. So basically we talk about here per meter square. Vector quantity. Why vector? Current is not a vector, but because of the area, area is a vector quantity. It is a vector quantity. Now electric current in the conductor. Conductor, we know it has free electrons, so that allows the current to pass, and because of that it is able to conduct. So it has metals, it has free electrons. Electrolyte, they have ions, charged particles. Okay, so ions are there, positive ions, negative ions, we know about that. Okay, not going much in details, not needed. Ohm's law, very important. What does Ohm's law say? That the current is directly proportional to potential. If you are keeping the other physical condition like temperature, pressure and all that same, if you increase the current, voltage also increases. If you increase the current, voltage also increases, or if you increase the voltage, current also increases. So V is equal to IR. R is the constant or proportionality constant. V is equal to IR. Ohm's law is nothing but V proportional to I, and this formula V is equal to IR. If anything follows Ohm's law, it is called ohmic conductor. If not, non-ohmic material also we can say. Now next is resistance. Resistance is equal to what? V by I. Resistance is equal to what? Voltage by current. Resistance is equal to what? Voltage by current. Unit is what? Ampere. Cut it. Unit cut. Okay. Unit is what? 1 ohm. 1 ohm is what? 1 volt by 1 ampere. 1 ohm is what? 1 volt by 1 ampere. I have given the dimension here, but still I'll be giving in the chapter dimension and analysis. Every important dimension I've given up there. Okay. So resistance is directly proportional to length, inversely proportional to area. So, and if you remove this proportionality, we get resistivity. So R is equal to rho L by A. R is equal to what? Rho L by A. Very important. Resistivity depends on the nature of material. Okay. So if you're changing nature of material means if somebody has taken copper wire, somebody has taken aluminum wire, somebody has taken something else wire. So this resistivity rho will change. Okay. And temperature. If you change the temperature, like somebody is working with a room temperature like 25 degree, somebody is working at a very heated temperature like for 50 degree. So at different temperature, resistivity also fluctuates a bit. Okay. Now, so from here resistivity is equal to what? AR by L. Correct. And resistivity is nothing but ohm meter. That's it. Now what is conductivity? Reciprocal or inverse of resistivity. That's it. So sigma is equal to 1 by rho. Sigma is equal to 1 by rho. Okay. So we write rho meter whole inverse or Siemens per meter. Conductance is reciprocal of resistance. G is equal to what? 1 by R. G is equal to what? 1 by R. It is also known as Maho, or what is your ohm inverse, okay, or Siemens. R is equal to a lot of questions, students, every year. You'll get in the form of R is equal to rho L by A. This formula is just important, okay? So you need to understand this. For this formula, what things they'll do it? They'll like give you a condition like where volume they've kept constant. And now they're telling that if we are increasing the length by double, what will be the change in the resistance, or increasing it by area, making it half, what will be the change in resistance. Okay, so R is equal to what? Rho L by A. Okay, now we need to make this what is say, we need to bring the constant volume part so that R is proportional to something with respect to volume and just one variable. So what you can do, volume we know already. Volume is equal to what? Area into length. Correct, everybody knows volume is equal to what? Area into length. So what we'll do, we'll multiply top and bottom by length. So what you'll get, area into length will be equal to what? Rho L square by volume. So this is constant, this is constant. So directly we can say now resistance is directly proportional to length square, and we can solve it. Now here again, R is equal to rho L by, now we have multiplied with area. Area top, area bottom. So what we got? Rho V by A square. So now we can say resistance is directly proportional to what? 1 by A square. That's it. Now an area contains what? Area of anything is, for a cross section is pi r square. So resistance is directly proportional to 1 by r power 4, or resistance power 4. Okay. Temperature dependence of resistance. So we know resistance at temperature T is equal to initial resistance at 0 degree into 1 plus alpha. Alpha is nothing but temperature coefficient into T2 minus T1, change in temperature. That's it. So this formula is important. Okay. If you try to plot in a graph, so what you'll get? You'll get R0 value, okay, and then a slope, and that slope is not nothing but alpha R0. Okay, so this is the slope, tan theta. So tan theta is equal to m is equal to alpha R0. So very rare questions are asked, but still you should know it. Okay, temperature dependence on resistance. Next, while solving the question, you will understand the way they ask it in the exam. Next is drift velocity. Now what is drift velocity? Velocity with which electrons they get drifted towards the positive element of the applied electric field. Now electrons, they don't move it like that. What they do, this electron will push the next, this will push the next, so they'll drift, okay, like this. Okay, so they'll drift and keep drifting towards the positive end of the plate. Okay, so one electron is drifting like this, another again drifted, another again drifted. Okay, so they are pushing the next one, next one, next one, next one, like that. So they have two kinds of velocity. One is the drift velocity and one is the thermal, their own velocity due to the thermal motion. Okay, or thermal velocity also we can say. It is because of their own kinetic energy, and this is because of the electric field by which they are attracted, they are pulled. Okay, simple. Now what is important here? This formula is also important. Electric field equal to potential across conductor by length of conductor. E is equal to V by L. Very important. We have done E is equal to minus dV by dr also. So E is equal to V by L. You will be using it a lot of times. So do mug it up, very important formula. Now, whenever you have an electron and you have kept in an electric field, force will be there. Now, what will be the force? Force is equal to what? Charge into electric field. So here it will be, in case of electron, minus E into capital E. Minus E for the charge and capital E for the electric field. Acceleration is equal to what? Force by mass, so minus E by m. So this formula also a lot of question, tumba question you'll see in the KCET part. Okay. Now, next, drift velocity formula, Vd is equal to what? Minus E tau by m. Now, let me explain you what is this tau, buddy. Okay, let's come and understand this tau, buddy. So, let's say every electron, they're randomly moving like this, is at a speed v1 is equal to, and final speed I can find it at what? v1 is equal to u1 plus at1. So, if I want to find the total drift velocity, I'll take the average. So, v1 plus v2 for n number of particles, vn divided by n. Now that I can write it as v1 will be written as what? u1 plus at1 plus dot 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 dot. It will be continued for all other plus un plus atn, correct, by n. Now, since they are moving randomly, so the initial velocities of all of them will be what? Getting cancelled, correct. So if I do the average, one is like moving this, one is like moving this side, okay, so it will all be cancelled. So what you'll get? A into this time average by n, and this time average by n is nothing but the tau, that is also known as relaxation time. Okay, so Vd is equal to a tau and a is equal to minus em by tau, em. So we can write Vd is equal to e tau by m. Very important formula. This formula you have to write it out. Even if you don't care about this, we don't need that much. Just for the explanation sake, I just gave it. Okay, this part is important, this part is important. Okay, next, relation between Vd and I, current. So current is equal to what? NA Vd. This is very important because they'll say sometimes they're increasing the Vd, what will be the change in current, they're increasing the area, what will be the change. So this formula you should know. Next, this formula, I is equal to, in terms of relaxation time also you should know, ane square tau e by m. Ane square tau e square by m. Okay, ane square tau e by m. So this formula also very important. What is n? Number of free electrons per unit volume, means in 1 meter cube how many free electrons you are getting, that is the value given by n, and volume we know al. Clear? Now coming to mobility. Mobility also they'll ask, what is mobility? Drift velocity by electric field. What is mobility? Directly said, drift velocity df by e. That's it. Okay. So next what you have is resistivity is equal to m by ne square tau. Now what is important here to understand is resistivity is directly proportional to 1 by n. Okay. Now we see resistivity is inversely proportional to n. So n is nothing but number density of free electrons. So basically n is number of electrons available per unit volume. So by that, if you increase that, the resistivity will decrease. Now resistivity is also inversely proportional to 1 by relaxation time. So you need to understand this all. This formula is also important. So what happens, as if the question will come, if the temperature is increased, what will happen? Relaxation time decreases. The moment relaxation time decreases, what will happen? Resistivity will increase. So this kind of questions keeps coming up. Got a bit of cold, okay, but today and tomorrow we'll put up everything, whatever happens. Okay, no excuse, we'll put up everything. Now resistivity is also rho is equal to rho naught, rho naught into 1 plus alpha into T2 change in temperature, T2 minus T1. That's it. Clear? Now this is very, very important. Okay, already told you current density is equal to I by A. Okay, now voltage is equal to, potential is equal to E dot L, electric field into length. Now V is equal to what we can write? I rho L. So V is equal to, we know what V is equal to IR. So V is equal to I into R, and R we can write it as rho L by A. So I wrote this one. Okay. Now V is also equal to EL, and that is equal to I rho L by A. So LL cancel Mari. Okay. So what you got? E is equal to, and I by A is nothing but J. So J into resistivity, and we know now what is a J is equal to electric field by resistivity. So that is equal to 1 by resistivity is nothing but what is a conductivity. So that is equal to sigma E. So J is equal to sigma E. Very, very important formula. Now next part, combination of resistors. 1 mark minimum, one question comes up. Okay. So series, a lot of question will do. Series, understand what happens, voltage gets divided. So the voltage here and here, the total voltage gets divided into two part, V1 and V2, correct? Now In series, what remains same? Current. See, since only one way path is there, where can current go? So current remains the same, students. Okay, very important. So it is also known as voltage divider circuit. So series is known as voltage divider. Parallel connection, what happens? It is a current divider. See, this current here, one part. Now let's say you have two friends, and suddenly you want to go to your friend, maybe friend one or maybe friend two. So what will happen? Either you will take this route, let's say some chances, you will take this route. Now current can do what it will do, it will part few of it. Okay, few of the part of the current will go in this, few will go in this. Now here a lot of questions without solving also you can solve by understanding. If resistance here, if this path is very tough, what will happen? Our tendency to go on this path will be less. Same thing current also. If it sees, oh, I had a very strong enemy is there, a very strong resistor is there, a very least amount of current will flow through this, and the maximum current will flow through this part. Okay, so we need to understand the current always chooses the path of least resistance. Current is more lazy than us. Okay, so it chooses the path where it has to work very less. Okay, so always remember it. Current chooses the path of least resistance. Say it with me. Current chooses the path of least resistance. So let's finish the concept together with me and you. Okay, so that nobody has any doubt, and we can put up the PYQ video so you can solve everything. And this 6 marks and 8 marks in physics, almost around 6 to 8 marks, you can make sure that that is yours. Nobody can take it. Now this is like a voltage divider. Okay, it is here dividing the voltage. Here the voltage is V1 in this, and for the resistance R2 it is V2. The current remains same. So everybody understood the basic of what is a parallel circuit and series circuit. Now parallel, what happens? Resistance get added, so we get max resistance here. And in series, what do you say? Sorry, in series we get max resistance, and in parallel, what happens? The resistance, the what do you say? Combined resistance becomes small. Okay, so we get the least one. So whenever they say two or five resistances are there, and we are trying to get the least one, so we'll go for parallel connection. And if we have to get a maximum, we'll go for series. Now, what happens whenever a current goes through the what is one of the resistor, voltage drops here. So how much voltage will drop? V is equal to IR. So if you know the current which is flowing here, and if you know the resistance, you can find it out. So we can find the voltage on each like that. So V1 is equal to R1 by total resistance R1 plus R2 into the total potential. Okay. Same thing for V2 also we can do. So that way a lot of questions will be solved by V1 by V2 is equal to R1 by R2. Okay. They follow this ratio relation. Very important. A lot of questions where there it is like 2 only, we can easily solve by this form. Okay, v1 by v2 in case of series is equal to r1 by r2. Correct. So see, it is like don't bug it up, because we already know v1 is equal to ir1 and v2 is equal to ir2. I cancel what, you will get this formula. So don't take something like something too complex. I'm telling you, nothing like that. Okay, it's pretty simple. Here I1 by I2 is equal to R1 by R2. Okay, same thing we have done. Okay, nothing more than that, if you understand. So this is also very important. Clear? Now for 3, I'll show you tricks how to solve it more efficiently. But still, if somebody is very good with the formula, they can mug up this formula and they can solve a lot of what do you say, questions based on this. So it will be easy. Okay, so it's like a what kind of base theorem. So I1 is equal to what? R2 R3 by total. I2 will be equal to what? R1 R3 by total. Okay, so you can understand like that. Same thing. Now, two laws of Kirchhoff's very important. One is junction rule. What is junction? See, this is the meeting point. At junction, what they're telling is how much current is coming in. So, what is current coming in the junction? I1 and I2. So, amount of current which is coming inside has to be same as the current which is going out. Otherwise, it's not Harry Potter movie. Correct. Current can't vanish. Whatever current came has to go also. Correct. So, that's it. Next, KVL, we apply loop rule. Now, what is loop rule? Algebraic sum of the changes in the potential around a closed loop is 0. So, we'll see how do we apply the KVL. Very simple. Don't get too confused. But before that, we need to understand the sign convention. Before that, we need to understand the sign convention. What is the sign convention? See, if the current is going like this and we are going in the same direction, understand, remember it like this, same. When it is same, we get a minus. So, when we are crossing, it will be minus IR. Current is going like this, but we are going opposite. Opposite means E plus IR. Okay, clear everybody? See, other direction is also there, but you should learn only one, otherwise you should not get confused. If you have learned anything else other than that, that is also like, that is also similar to this, so you can do that also. But it's same thing. If you can remember like this, if the current direction and our direction is same, then we get a minus. If our direction and current direction is different, we get a plus. So current direction, if your current direction and our direction, the way we have taken the loop, okay, is same, then we take a minus. So same means minus, opposite means plus. Same means minus, opposite and plus. Okay, write it down 2 times, you'll understand. Now whenever we are encountering a what plus sign at the end, if you are getting a plus sign of the battery, we'll put a positive V. Okay, and whenever we are getting, if you are going it like this, and at the end we are getting a negative sign, we're leaving out with a negative sign of the battery, it will be minus. That's it. So this much you know. We'll see how to put it up in here. Let's say we have a loop, big loop like this. Okay, we'll try to solve questions without this also. Don't worry, I'll teach you in the PYQ section. Now, understand, we have taken this whole condition and whole setup. I'm doing for the loop A, B, C, D, A. So I'm going from A, I'm getting the first resistor, I'm going to B, and from B, after that I'm getting a battery. I'm coming to C, from C I'm getting again resistor, coming to D, again a battery, and then I'm coming to A. That's only I'm doing correct. I'm going it like this. So just now what I said, if I'm going my direction and current direction, my direction is what? A to B. Current direction is also what? A to B. If both are same, same means what? Negative. So it will be what? Negative. Negative for the resistance. What is the voltage at here? IR. So what is the current flowing? Minus I1. And what is the resistance? 4. So minus I1R, and in this case the R is 4 ohm, so it is minus 4 I1. Correct. Next I'm hitting a battery. So what I told, whatever the outside, the leaving part of the battery is, if it is a positive, big danda means positive. If I'm seeing a positive, what I'll do, I'll write plus 4. Clear? And then I came here at C, I drank some tea and all, and then again I'm going in the current direction. So again I saw a resistor. What will happen? Same direction, come on. What will happen? Minus, again minus. So voltage here will be minus 2 times of I1 plus again. Now see here, first I saw a negative, but at the time of leaving, what I got? A positive of the battery. So again plus 2 is equal to 0. Correct? So everybody, I think so you got this concept, okay? How to apply the KVL. So again understand, from A, I'm going, okay, my direction is from A to B, current direction is also same, A to B. So if we both are going in same direction, what will happen? The voltage drop here will be minus IR. Minus I current was I1, and R is the resistance, that is 4 ohm. Okay, so minus 4 I1. Now coming from here, I'm first seeing the negative of the battery. You can understand with the negative of the battery. If somebody likes, if I get the negative, I'll write it as positive. So plus 4. Or you can understand by this, if I'm leaving this battery and I'm leaving from the positive side, I'll write plus 4. Next, I'm going to C, and after that, again, I'm going in the direction of the current. Again, it will be negative IR. I here current is I1 and the resistance here is 2. So minus of that. And then again, I'm going leaving the battery of the positive side. So it will be plus 2. And that whole thing is equal to potential, what is the sum of all the potential in a loop is equal to 0. That's it. Clear? Now for the loop B, E, F, C, B. This will be yours homework. Put it on the chat section. I'll see how many students have done correct. Okay. Next is Wheatstone bridge. So Wheatstone bridge is pretty simple. Okay. So you need to understand. I haven't given the diagram. Diagram is the next page. So what happens is you can get different types of Wheatstone bridge. Okay. I haven't put up the what do you say? Yeah, you can take this one only. So if it is in a balanced condition, let's draw a Wheatstone bridge. Let's see here. Let's say we have a Wheatstone bridge like this. Okay, one resistor here. We came at this point, let's say B. Now, mostly the question which will come will be using the balance condition. What is that balance condition? Let me tell you. This is a battery here. Okay, so here let's say point A. Now, when I went from A to B and when I went from A to E, the potential at both, because see, this one is resistance. Let's say in this case R1, R2, R3, R4. Okay, so the potential here at VB and the potential here at VE, these two potential are equal. Now imagine if the potential here and here is equal, any current will flow in this circuit? No. The galvanometer, the current in the galvanometer part will be equal to 0. So when that happens, we say that the Wheatstone bridge is in balanced condition. The Wheatstone bridge is in balanced condition. The current here is nil, no current, because the potential at B and the potential at E is same. So if potential is same, let's say two jugs are there and the water is fully filled. You connected a hole and you connected a pipe. So will anything go the same height? So no pressure. So if there is no difference in the potential, why will electron be going from here to here? Nobody will go. So if the potential as these 2 points will be same, so in that case the product of this resistance into this, like this, and this into this, R1 into R3 is equal to R2 into R4. A lot of people, they'll what is it, remember like this, R1 R2, R1 by R2 is equal to R4 by R3. You can do by that, okay, or you can do by R1 by R1 into R3 is equal to R2 into R4, both ways. Okay, now sometimes we'll get similar questions like this. Like this is also Wheatstone bridge. If you just pull it up from here and here, you'll be able to see it. Okay, this one also, if you join it like this, you'll be able to see. Just pick it and lift it up. Okay, you'll be able to see. It will be similar to this. Okay, and directly then you can apply R1 R3 and R2 is equal to R2 R4. Correct. Wheatstone bridge, directly you can apply. Basically 99% case they'll give you balanced condition. Okay, so direct. If not, we can use KVL case here. We can use the KVL part and we can solve it. So don't worry about that. Okay. What is electromotive force? What is electromotive force? EMF. See, when you have a battery and you haven't not connected with the circuit. So now what is the voltage here? That is the EMF. Clear? And there in this case E is equal to V. The moment you have connected the battery, okay, the moment when current is 0, what is the voltage? That is equal to EMF. The moment you have connected with, so what will happen now? What will happen? The moment you have done a circuit, so a few part of the battery, a current will go to the internal resistance also. So that case V is equal to, the potential develops is equal to, original was E before connection minus the drop due to the small resistance. So V is equal to E minus IR. So now that is known as terminal potential difference. What is it known as? Terminal potential difference. Okay. Internal resistance, how will you find? Send the E that side. Something I've written wrong. Okay, this is wrong. R is equal to E minus V by IO. Okay. E minus V by I. Okay, clear. Next, cells in series, very very important. Now you had one battery, and in childhood days we have connected lots of batteries. You started connecting batteries. Then in that case, if you have connected n batteries, okay, what will be the total current? I is equal to, total EMF will be NE by total small resistance will be what? NR plus one, that big resistance here. What is it? Whatever the external resistance. So that's it. I is equal to NE by NR plus R. Now, a very important question. You have, let's say, for 5 batteries. Out of 4 are in like in series connection. One is opposite. So what will happen? This E5 will cancel the E4 if they are both identical. E5 and E4 will be cancelled. So how much will be left? Though we have 5, 2 of them got destroyed because one was positive, one was negative. So they got destroyed. So we have just 3. Okay. So that form, in that case, if M cells are reversed, so what will happen? N minus 2M means each M cell will destroy 2 of the cells. Okay. So N minus 2M by into E by NR plus R. Clear, everybody? Okay. In case of parallel, okay, in case of parallel, R equivalent you can easily find for the small ones. Capital R plus 1 by sigma of 1 by R means just basically the same parallel formula for the resistance, internal resistance. So I is equal to sigma E by R by 1 plus R into sigma 1 by R. So this will show it how to do it in the PYQ section. Don't worry, but it is very important. Next, meter bridge. Meter bridge also, it's very similar to the Wheatstone bridge. Instead of just resistance, here we have the length part which is behaving like a resistance. Okay, the wire which has, what you say, because we know if R is equal to rho L by A, and if we keep this area and rho same, so what will happen? R is directly proportional to L. So in that case, the length will behave as a resistance. So that only we done. So R into 100 minus L, see opposite, R into 100 minus L is equal to S into this L. That's it, done. Clear? So you can do that one. So if it is L1 and 100 minus L1, okay. Here also same thing, opposite. So R opposite you multiply R into 100 minus L, and that is equal to S into L. That's it. Now potential meter, we use potentiometer to find EMF, to compare two batteries also, and to find the internal resistance of the cell. So first we use the potential gradient. Potential gradient is what? Voltage by length. Potential by length. Okay. Potential gradient is nothing but fall of potential per unit length of potentiometer wire. Means if I'm moving 1 meter of wire, how much voltage is dropping? This is basically the meaning. So what you can do, we can use this formula. I'm not going much in details. E1 by E2. So when we connected one of the battery, the fall was this much length. When we connected the other battery, the fall was this much length. So E1 by E2 is equal to L1 by L2. Done. Okay. To compare the EMF, first you put the E1 battery, get the length L1, then you put the E2 battery, get the length L2. Now you can compare which one is more, which one is less. Okay. To find the internal resistance, we have the formula. Directly you need the formula. Okay. And you can use this formula. R is equal to small E by V minus 1 into S. Okay. And you can use also in terms of length, E by V can also be written as L1 by L2 minus 1 into S. That's it. Okay. So the whole current we have this much only. Okay, go through each and everything. Almost each and everything will be clear. It's very simple. If you have doubt, put it in the comment section. We are bringing up a lot of things by these 2 3 days. So start working hard. 10 days is also more than enough. If these chapters are very strong weighted chapters, 6 marks. If you solve it, everything of this and the PYQ, the way we are solving, you'll be able to solve each and every question in the exam also. So don't worry, panicking won't help. Even students who haven't started, okay, let's say you are at the zero position. From here you start building up with the strategy. Go with the important chapters, see what is there, and without panicking start studying. Forget about what will happen, how not will happen. Start searching for tricks, how to study without how to get marks in KCT without what you say studying and all that. So don't do all that. Okay, because not all the tricks works. And for the students, since a lot of students they have requested, what are the real tricks we can apply in the exam? Okay, so after the syllabus is done, from 21st we are bringing the trick buster series. So you don't have to search, the series will search each and every trick available, and will show you in reality check which tricks work and which trick doesn't work. Okay, so do inform your friends of the trick buster series. Okay, and we'll try to put up each and every content which we promised by today and tomorrow. Okay, so work hard.